Alright, we want to talk about determination of boiling point. This is experiment 2 in your manual. So please, I would like you to open your manual to page 8 and let's discuss about determination of boiling point. Now, we all know that a liquid starts to boil, or let me put it this way, you should know that a liquid will start to boil when its vapor pressure is equal to the prevailing atmospheric pressure. Now, the temperature at which a liquid is at equilibrium with its vapor pressure is called the boiling point. So a liquid gets to its boiling point when the temperature of the liquid is at equilibrium with its own vapor pressure. And where is the temperature of the liquid coming from? It's coming from the prevailing environment where the temperature is gotten from. You understand? By the time you heat up water, it's an external thing. So this temperature penetrates and enter the water and give the water the temperature you are actually recording. Now, at that equilibrium, when the temperature of your liquid is equal to the vapor pressure, we can say boiling takes place. And as a reminder, you should know that a pure sample or a pure liquid will boil normally at a very small temperature range. As we have discussed a melting point before too, just as melting point is a useful physical property for indicating the purity of an organic compound and also identification of such organic compound, so also your boiling point is very useful to do the same thing. You have a table given you there showing the boiling point of several organic substances. There are still so many others. You can look up them in books. Now the procedure is well stated. Now the point is we need to have an understanding of what happens to boiling either without a pressure cooker or with a pressure cooker. In a normal setting or at higher altitude. I'm referring to a normal setting as we are now in Anchor University. We are not at any elevated height, so we can take that as a normal setting. Now you should expect a different scenario in a higher altitude, like going up in the sky, like when you're in the airplane and so on. Now there are other heights that are even higher than that. Now, from the questions in your booklet, you are asked to state the boiling point of a sample. This we can get if you actually carry out your experiment. You will get this. Number 2, from the boiling point obtained, you can now identify your sample. If the boiling point you record falls in line within the stated boiling point, then you know that boiling point is indicating a particular organic substance which you should give. Now, question 3 is the bone of contention. Even though it's just 1 mark, but at the same time, we need to know it, because if you don't understand this setting, you may not be able to answer this question correctly, and at the end you discover that by the time you are giving your answer, you'll be contradicting yourself. So you need some good explanation. So the picture showing on the screen is just trying to tell us the impact or the usefulness of pressure cooker at a particular height. Here you can see the altitude and the pressure cooker is meant to be used. So we'll move on to explanation of what happens in a pressure cooker at a height of 10,000 feet and also without a pressure cooker at same height. Thank you. Let's move to the second slide.